So our speaker tonight is Xander Breg. He is a data scientist at Ford Motor Company, where he works primarily on answering questions about powertrain using data. His past work experience includes powertrain testing and systems engineering at Ford, and he also worked on nuclear reactor fluid systems in the Navy, which I was in the Navy too. So Xander and I have a couple shared work experiences. So I'll hand it off to Xander now, who will do the presentation on time series analysis with Panda. Thanks, Xander.
Thanks, Dan. Yeah, I'm Xander Breg. Well, thanks for the introduction, Dan. For the talk tonight, I'm hoping to just touch on a few things. We've got about 40 minutes. Dan and I went through this. It took about 30 last night, so we do have time for questions. So feel free to interrupt, or we can go through things at the end. I've got the Jupyter Notebook open in the background, so we can kind of play around with things as time allows. The main things that I want to touch on as themes, besides just the time series analysis, which is the coding, which might not be quite so interesting. There's a lot of little details, and it's much more interesting to be hands-on. I will, show code, and we'll try to be hands-on at the end. But some of the big things I just want to go over is expose people to Pandas, expose people to Jupyter Notebooks. This presentation is built on Prezi, which I think is a little bit more conducive to presentations and telling a story, which is hopefully what most presentations do. So that's, and then some of the real world problems. And as a fairly junior Python programmer myself, I do want to talk to more junior programmers and talk about real world problems and kind of silly things that I've run into, that mistakes I've made, and hopefully encourage people, because I know it can be very intimidating with the expertise in Python and in computer science. And as more people move into data science, as I have with an engineering background or some other background, I think it's important to just kind of support new programmers and realize how difficult some of these problems can be the first time around, and provide encouragement as well. So again, I just want to expose people to some new tools, go through an interesting problem, a novel solution. I think I tried Stack Overflow. This was, I had to invent something myself, inspired by somebody else, but I invented something. So hopefully a novel and interesting solution as well, and give people some new Python programmers, especially some good practices to focus on. So with that, I'm going to kick it off with the background. Talking about myself a little bit further. So moving from an engineer working on single vehicles and bench simulations, and also software simulations in order to validate requirements and troubleshoot problems on specific vehicles, you end up in these graphical analysis tools. You've got this time series data. You kind of just watch as everything traces across the screen, time on the X, and then all your different signals on the Y. So that's kind of my background, first starting at Ford. And so then I became an expert on a particular feature in automobiles. And so then I'm writing scripts and processing data for this feature across a lot of different vehicle lines. So again, adding complexity as we go. And that's, our world in general these days. So important to learn how to manage that is kind of what I want to get into as well. But now I'm collecting data on a lot of vehicles at once remotely. So I don't even see the vehicle. I don't have hands on the vehicle. I don't have an engineer as before with hands on the vehicle to give me some more expert analysis. So now as a data scientist, you're working on problems much more remotely, much more distant from the actual hardware, and engineers should, I believe, always have hands-on as much as possible. Keeps you connected to it, but this is a reality I live in. And then moving from specific engineering cases to how people use vehicles. And so that makes the problems a little bit more difficult. You have to define your problems as you go. It's a very open-ended field, and you can ask any questions you want. You've got all kinds of data to play with, versus before I wrote the tests and what are we trying to validate. So it's a much more open-ended world. So I just want to talk about that just as a background to set the stage for what we're going to get into a specific problem today. So next up, we're going to talk about Pandas real quick. So Pandas is a Python package It's super popular. It's in the data science community. It's all about data manipulation and analysis. So if you're familiar with SQL, a relational database, it looks like a SQL database to some extent. And here's the bread and butter of Pandas is the data frame, where you can store data of all different types in a row and relate them to each other and have different entries. You can even store series inside of a cell. So you could have the number of points per game in here, for a player on the Celtics, for instance, in one cell. So it's highly flexible, and there's a lot of different operators that can operate on this very efficiently. And so that's kind of what we're get into. First solution will be a more traditional from your CS 101 class to a more Pythonic type of answer with the data frame and pandas and I'd say also feature extraction. As someone who's done a little bit of machine learning, you're kind of pulling apart the data little by little, the time series data. So, so here's just an example, pandas data frame histogram. So here's a very basic pandas operation. You can see lay out the data as a histogram. You have different bins, the frequency within the bins that the data lies in those. So that's just a kind of basic way that Python can display the data. It has got a little bit of time series capability within Python, but we're going to expand upon that with the problem we're going to work on today. Here's the other tool I just want to introduce that I use frequently at work. It's called Jupyter Notebooks as part of the Anaconda data analysis package, data science suite. It's a few years ago, my friend introduced this to me and I was really taken aback, used to MATLAB and C coding and interpreted, MATLAB is interpreted, but C code would be something I have to compile. But Python's really cool for playing around. And so Jupyter Notebook takes advantage of that. And it's kind of a scratch notebook, I call it. You can create chunks of code and run the code independently. Not that you can't do that in MATLAB, for instance, but it's just nice to have a notebook, and then you can kind of see down here, you've got your graph as a part of your notebook. So you save your code with your output. And so it's good kind of at the draft level to show people what you did, and then they can look at the graph and see if that's interesting, but then they can go back easily and see what code led to that. And they can kind of check your code, or they can manipulate the code. So I find Jupyter very useful. We're going to get into it at the end of this, but just wanted to lay it out there in the background. So on to our, I guess, any questions before I move on?
So we did have a question in chat. Suresh, hi Suresh. He was asking, how do you decide when you use Jupyter Notebook or any other type of IDE?
Yeah, that's a good. And as I've kind of gone through the data and gone through different analyses and getting to presenting the data, I've gone to Streamlit, which is another Python package, to present the data in kind of it's a pretty quick and dirty way to get from Python and data frames into a website and something that you can serve. But what I did basically was I went through the Jupyter Notebook and the different chunks of code, and then I moved it over into, it was just idle, very basic editor, and then ran it and saw the output in the Streamlit. But so for me, I think when you're developing something, you want to use Jupyter Notebook just to kind of get quick results and play with things. But then when you're making something like an end use data flow or workflow, then I'd move into an IDE like Spider or Visual Studio, or even just idle to run the Spider code, because at a certain point the code just becomes a text document with .py at the end of it. So that's kind of my breakdown, and we'll see that at the end how nice it is just with Jupyter to play with things. It's kind of your sandbox, I describe it. Did that make sense?
Thank you.
Yep. Okay.
Yep. Thanks.
So the problem today, so there's a lot of different sets of data. Some of it is, you look at a population, what's everyone's age? You want to describe the population. You want to describe where everyone's from. You want to describe the height of buildings, things like that. Those kind of data sets go well into Python, but in my domain in vehicles, you kind of want to know you're looking really for time series data, what happens from one moment to the next, again, to describe how people behave and describe how the vehicle is operated. And so even then, you're just kind of sampling data, looking at what happened. You want to know how fast people drove, and so you can just block that out as a histogram. How efficient was the vehicle operation? You can block that out by time or distance or something like that. But sometimes you don't just want to get an aggregate and look at the 95th percentile to describe a population. You want to pull out events in the data, and you want to look at continuous events, and we'll kind of go into when that's important here. And I guess this is a question for everyone on the call. What if your problem depends upon what occurs over a time threshold and exceeding that threshold to do something, to go for a run, like an interval training, and you run for 60 seconds straight or 90 seconds straight, and you hit that threshold. Can anyone think of problems or situations you could describe where things are okay until you reach a continuous threshold in either a time or a different domain, where you can't just look at the data individually?
Can you use the data for recognizing events, certain things that happen that have some type of signature on them?
Right. Yeah, absolutely. Yeah, that's kind of what I end up having to do at work, is people want to collect a lot of data and say, well, did the people do that? Does this occur and how long is it? Any other thoughts on when things, it almost becomes a life question. So don't get too technical about it. Is, just like an annoyance or anything, if something goes on for too long, it goes from an annoyance to a real problem. So I'm wondering, can anyone think of things like that? It's health, science, engineering, any kind of problem like that.
I mean, I don't really know, but one problem with continuous variables might be that things become kind of vague, that they're not well discretized, so you can't really tell exactly when things are starting or finishing, or how much of something there is.
Yeah, that's a big problem I ran into with the data is, we get data from the vehicles and we're not quite sure what the person is doing, right? And how to define events even. And I will touch on that, absolutely. Kind of the ambiguity of a lot of these problems. But so here are a few ideas I came up with. So we've got, rainfall, for instance. You have rainfall evenly spread out over time. It gets absorbed into the soil. Plants get to grow. We harvest the plants, and the farmers have a good yield for the year. But what happens if you get a lot of rainfall continuously on one day? What if all your rainfall comes in a week, right? Then you've got flooding and the crops are destroyed or damaged. That's just an agricultural example. Another related, that's the time domain. This is going to be the stress strain domain. So strain is an engineering term for displacement. So distance of pulling like a rubber band. But so in this case, you've got elastic deformation like a rubber band. It goes back to its original shape after you deform it. But then you hit this regime like putty, where the deformation is plastic and it stays after you displace the material. And so you've got, you care, once if something occurs within this domain, it's one thing, but then once you get past this yield point, for instance, you've got a real problem, or you've got plastic deformation at the very least. Maybe that's what you're trying to achieve, but you can't just see like the force applied like a spring and find an average or something. You care about the continuous, again, this is not time, but this is distance. You care about the continuity of that data. You can't just aggregate it and look at, the force at, average force or something applied to the spring. Other things, again, just nuisances, like you have a problem starting your car or starting your computer. If it happens once in a while, it's fine. But if it happens 5 times in a row, you're going to take it, you'll have it towed to the shop, or you're going to call IT, right? Same thing in a biological domain, heat exposure. You go out and you get, it's hot out in Arizona, we go to the car, that's not a problem. But if you go out and you stay out for a long period of time continuously, your body gets overwhelmed and it can't cool you anymore. And then you get to heat exhaustion, for instance. So sometimes you need to describe and look at data continuously. You can't just aggregate it. Any other ideas after looking at those? So I would describe this as a healing or recovery period. If you can heal and recover after some stress, you can. That's kind of these type of problems, I'd say. Just another way to look at it.
Would working out in a gym be something similar?
Yeah,
where
exactly.
You lift weights and then you recover, you lift, you recover.
Yeah, exactly. It's like, I go to the gym and I'll lift a weight, 12 times and I can't anymore, but then I put it down, I take a 5-minute break and I can lift again, right? So same kind of situation where the continuity is important to have an event. Similar, now we're going to kind of like look at the data. So here's suntan, sunburn, here's the histograms again. UV index, time and hours, annual exposure. And so people get a lot of, these two people get the same profile of UV exposure in aggregate. But we're curious if they get a sunburn or not. And you can't really tell that from this data. There's potential for it. You've got high UV index, but we're going to look in here and see, for instance, person 1 gets a suntan because he's a retiree and Florida's getting limited amount of sun every day, and it's throughout the year, so the continuous exposure is limited. He's also smart and he wears sunblock, but the idea is we care about how much of this occurs continuously, this exposure. So person 2 gets the sunburn because they're from Michigan and they get all their exposure in a 1-week trip to Disney World, and so you've got a lot of continuous exposure. You could also aggregate this and look at on a daily basis, but some instances like I had to do for work are event by event. And it's the same kind of look at it. So we're going to try to answer this question of looking at continuous exposure with that preface. So let's get into a problem statement, look at some data, and here's our sun exposure levels, burn time. If you have a low UV index 1, 2 is 60 minutes, moderate 45 minutes you get burned, high is 30 minutes, and then these higher ones only 15 minutes you can get burned. So here we've got our indices, and we've got the time length that we want to monitor for concern in our data set. So with that, we're going to go at the 2 approaches. We're looking for this spike above this threshold, made up threshold here. This is what we're trying to identify. And again, this is something I could do manually in the graphical analysis tools for one vehicle. I could look for an event, and I've done it by hand a bunch of times. But once you start looking at hundreds, thousands of vehicles, you've got hours and hours and hours of data. You can't do this manually. It's not cost effective. And it's pretty darn boring. So we're going to try to automate it and look at use pandas to do that. So first will be a for loop, and the next we're going to use start and end and use feature extraction to describe this. And it's faster, more efficient. So let's go take a look at those 2 approaches. So here's our for loop approach. Spoiler alert, it took 4.5 seconds to process the data. There's 1,000 rows of data of this UV index data that I generated. 100 runs took 4.5 seconds with the time it application. Another useful thing to know about in Python is there's this time it tool that allows you to time your execution. So when you're going to operate on huge amounts of data, you know how efficient your tool is. So for loop, traditional from your CS class. Here's my function definition in Python. We're going to look at max events above. And that's what we're really looking at to see if we get a max event above our threshold or UV index, those times we knew for the certain UV indices. And then we got an event counter for each event. And then we're going to loop through. And then, so basically all I'm doing here is stepping through the data with a for loop. For the index in the data frame index, we're going to walk through and do an if-else statement, looking at the UV index in the data. I'm going to switch to the I'm just going to switch for a second back to give you a look at the data. It's in the notebook. So early look at the Jupyter Notebook. There we go. But so I just initialized in Pandas a random data set from 0 to 10, which are the UV indices as we saw, 0 being nighttime. And here's what it looks like in the aggregate, looking at a histogram. And then here's what it looks like looking at its time series with our minutes on the bottom and our UV indices here. So we're going to process this data, just walking through the data. Here's an example of what it looks like. Or let me just.
So just quick question.
Mhm.
So what you did is you generated a time series, and now you just want to see if basically if one person got through a certain amount of radiation in, I don't know, last 10 days or whatever, last 10 times, right? And you just want to see like basically like the integral value for the last 10 and see if it's dangerous enough that they got sunburned. Is that kind of the overall idea where you're going? Or?
Yeah, exactly. That's a different way of doing it. Absolutely. It's definitely an integral. I've kind of, I don't know if I've simplified it or not by just saying that, you know, I've got these, my data or my rules of thumb are that table that we looked at back here, just saying that if you have an exposure over this amount for this amount of time, right? So obviously you could look at these and integrate and say, if I have an exposure over this amount, you know, UV index times time or something like that, right? That would be maybe equivalent, but I don't have that type of data. But absolutely, it's definitely an integral type of problem, integral situation. I did that in an electromagnetics class. We looked at the radiation from the sun and looked at the radiation and what's dangerous for people. So there's definitely another approach to this problem, absolutely.
Yeah, anyway, thanks.
I have a question, if you don't mind.
Yep.
What was your learning curve on Pandas? Was it something that took you forever? Did you find it intuitive? And the reason I ask is that, you know, I've got some experience, for instance, with Excel and the Microsoft suite, and a bit on SQL. To go to something like Pandas, what sort of time commitment do you think there is?
I think it's tens of hours. I've done tens of hours of training videos just to get, honestly, just an inspiration, because you end up, when you go to do it, you forget it, and you end up just Googling constantly how to do things. And I've got some MATLAB background as well, so it's not the easiest, I would say. And I think the biggest thing for me from Excel, for instance, is Excel's very graphical. And so you've got to, and I'll talk about that at the end. I think it's very important, maybe it's just for me, but in general, to have a look at your data. And that's, I wanted to come into the notebook and show you, this is what the data looks like. You know, here's the minute index over here, our x-axis, and then, you know, y-axis dependent variable here, the UV index. You can kind of just see the data. And we got to process this data and see when we're exceeding different UV indices and for how long. Is what we have to do. So you could do this manually. You could say, all right, index above 7 is 8. That's true. It's good. Okay, not here. So it's not continuous here. So we don't have an event.
Do you find yourself exporting data to see what it looked like as you were going forward, or did you find working inside of Pandas okay by itself?
I definitely take looks at data outside of Pandas, because it'll simplify things, and I think there's a learning curve to navigating the data as well. So like, here's what, you know, just looking at this first index looks like in the Jupyter Notebook, and then there's also, you know, some other handy tools. There's definitely a learning curve with any, for me, anything where you have to type it versus just look and use a GUI. There's just going to be some time to know what all the commands are. Like, here's the dataframe.head. So here's like a look at the data. So now I can see all the columns and a sample of the data, for instance, right? So you can take a peek at the data.
Sure.
And then otherwise, you've got to do things like look at, you know, certain indices. Let's just say we want to see, you know, maybe in the middle somewhere, 200 to 210 would be this command looking, defining the indices.
Yeah.
So not as easy as just scrolling through an Excel sheet, but I think the big thing for pandas is when you get to big data sheets and you've got to scroll around all over the place, you do want to be programmatic and you do want to start thinking about, all right, well, I only care about the times when the index is above a certain value. Those are interesting to me. So I think it pays off when you get to larger data sets to use pandas, right? There's some curve, there's a cost benefit. And it's definitely with bigger data where you want to start thinking about it more mathematically. That makes sense.
Larger, and from what I'm hearing in the rest of your presentation, more complex data is where the benefit is as well.
Yeah, absolutely. And when you're going to, well, it comes back to a lot of data, but when you want to do a lot of different analyses on the data and you want to do feature extraction, which we're going to do here in a minute, yeah, that definitely is where you want to have it all programmed out. And that's something else I learned handling things one by one was when you do it once, it's okay. When you do it twice by hand, you end up needing to do it over and over again. And that's when you want to start thinking about scripting and programming your workflow. Because once you have it down, it reduces errors and makes your life easier. You can process more data. So,
okay, thanks a lot.
Hey, Xander, we also had a question on chat. Mitchell asked, hi, Mitchell, is the data that you sent automatically from vehicles during daily use, or is it collected when the vehicles are serviced?
it's both. There's over-the-air technology, so we can collect data kind of hardwired into the vehicle or hard programmed into the vehicle, and it automatically sends data to us. But then there's also an ability to send commands to the vehicles over the air remotely. Yeah. And there's data that comes, dealers as well. So just back into the for loop real quick, just giving you an eye on the data frame. So we're just doing a for loop. We're saying events, we're just incrementing the event counter +1. And then when we get to a time when this comparison isn't true, we do a comparison to say which is the max, the events in this event or the events max that we're keeping track of. Store that to max events, and then we reset our event counter. So we're just walking, just logically, we're just walking one line at a time through the data and keeping count in our pocket, basically. So that's just how I think of it mentally. And then at the end, we do the comparison, was our max events above our burn time? And it prints out the number of events and whether the person was burned or not. I'll just show that real quick again. Calling the command, this is what it looks like in Jupyter Notebook. But again, Jupyter Notebook's nice because you can call the function here, and then I can call the other method that I used. And so you can see side by side is just one way of doing it, but I've got a record as well. I can save this notebook and all of these outputs are saved as well. So I can see that when I use the same, here's all of our times and UV indices. And if I call the same ones in the different programs, they come out to the same answer, which is nice to know when you're testing your software. So back to this. So now on to a little bit more Pythonic way of doing this. This is a little bit more just CS 101. Doing feature extraction on a data frame, which you saw a sneak peek of in the notebook, but it's about 4 times faster over the 100 run time it execution that I ran in the notebook, just to get an idea of how long it takes and how computationally intensive it is. So first step is, here's our first, let me go to, I don't know, full screen. Excuse me. Here's our index, here's our first element. And so the first one we do is just a comparison, whether it's greater than the index that we chose, which was low, which is 1. So 9 is greater than 1, we get the comparison to be true. That's just step 1. So we just want to know this. So this first column for us is just carrying that comparison Boolean thought. So it's, now we've got a feature extraction of the row. We know that it's true, it meets our criteria. So that's just one form of feature extraction, just terminology too, to say feature extraction is more machine learning. And then we care, we want to know if is this the first event? Did something change? Do we go from an event being true to not, or criteria being met or not? So that's this value difference. Did this value change from before to meeting it, this comp value? And so we do data frame dot comp the column diff not equal to 0. Is this difference not equal to 0? So there is some change. There's not equal to 0. So that's where we get this value diff. So you could think of this as a feature extraction of my event started. Here's something changed. So that's what this is keeping track of here, this column. And then you go to the value change. So there are some elements in the data frame where there's a change in the value. This change is not equal to is something other than 0, but then is not an event. So it's the start of an event that we don't care about. So that's where this comp diff value comes in. So this is just sifting out, filtering out the events that we don't care about. And then this comp def, so we're just summing. So here's just a data frame command in Pandas, comp diff cumulative sum here. And then we're summing this, and that becomes our label. So every time this increments, we get a new label. So it goes from 1 to 2 here, for instance. So again, feature extraction, now we have a label or a name for this first event, which again, we don't have before. We just have the UV indices here. And then here's another thing where here's an event, it's not greater than 1, it's equal to 1. So we do a multiplication on this, again, comparison being failed. And so we have a label, and this becomes a 0. And so we don't count that in our label plus comparison. And so I've got index 1 here of, again, events we care about. And then number 2, here's 3. 3 is greater than 1. So now we have our next event. So we got event number 1, we've got event number 2. Again, we're just walking across the data frame, creating new columns, extracting features. And so you see here 0. So there's a lot of zeros where we're not meeting the comparison. There's 148 rows like that. So they kind of become their own number of rows, and we're going to exclude them from the analysis. But so almost done. So now we've got our number of rows command. So we just do a map. We map a function to the column number of rows here in the data frame, and we just count the number of times this value occurred. So this value of 1 occurred 8 times in this data frame. So that goes into our number of rows. So that's what we're looking for, right? Is number of rows in the event. So we're almost done. Also note that we're storing in the data frame. I guess before we were getting rid of the event. If the event wasn't greater than the max, we just got rid of the data. But this is storing it in the data frame, so I know how long each of these events are, even if they're not the longest, and I can do a group by later to get some more
Xander,
data out
can
of
I
it.
ask
Yep.
a question about the data?
Sure.
Are these events, if you go back to the table, the data frame, and look at it, can we look at it right now when you're?
Yep.
Well, I mean, the thing that you were displaying.
Oh, yep.
So
this?
are we
Yeah.
looking at records here? Record 1, record 0, record 2, record 3? Is that?
Yeah.
And I'm wondering how an index of 4 is an event if you have a threshold that's 8, for example.
Yeah, so that would, I could rerun with a different index, and then the 4 would not count, right? This row
Okay.
would be excluded. Absolutely. Yeah.
And what's your comparison for this?
This is
2?
1.
Oh,
This is 1.
okay,
Yep.
got it. Okay, now I understand. All right, thanks.
Yeah, thanks for the question.
Yeah, sorry, this might be the same question, but I actually am a little bit confused how you define events.
Yeah, so for this one, this specific example, I guess I'll just dive into the notebook because we can do whatever event we want. So let's run it for whatever type of event we want. So let's say the burn threshold is moderate, so 3. So let's just copy this variable in here. And let's copy the time. And here's the data frame into the function. And now let's look at that data frame, the results of it. So again, our index is 3. So we're looking for greater than 3. So the 0 is not greater than 3. Everything else here is. So this is our first event. I can give you a few more rows so you can actually see it end. One more. Yeah. So greater than 3. So the 1's not greater than 3. The event ended. And so we've got 12 elements in the first event. Does that make more sense?
Yeah, I understand now. Thank you.
Great. Thanks for the question. So that's how the group by method works. And then we can aggregate. So here's similar example, but so at the end of it, we can call group by. And so it's group by operates on the data frame. If you tell it, so here's our label, here's the name of the different events, label comp, you can do statistics. So once we have everything split into the different labels or names for the events, we can do the size of the events. We can, and that's another way of getting how long they are besides calculating consecutive rows. And we can pull out the ID from the first element of it so that, down here I can see, how many consecutive events were there per ID. So I now have, if there are multiple people, I can see person 1 had 3 consecutive events, 4 consecutive events, and then person 2 had 3 and 2. So I'm extracting information from the original data set and putting statistics and organizing it to it. And that's what Pandas is all about. And group by is really powerful for sorting through data and applying operations. In my case, I cared about different events. I cared about different vehicles. So group by enables a lot of statistics. Once you've done this feature extraction, a lot of statistics to be performed on the data and stored for you. So I guess with that, any more questions about it?
Yeah. So frequently when you get data from anywhere, I mean, they're all not going to be fully populated, right? All the columns or some cells are going to be, and then is there a way here where, how would you approach something like that when the data you get is not complete?
Yeah, and that's a big feature of Pandas that Pandas is able to handle for us. Is there's a command, real world problems. You're good timing with your question, but drop NA. There's different forms of not a number. There's not a number. There's other types of null values, you could say, in Pandas, and so you can use this drop NA on a column or multiple columns or an entire row. You can do if any columns have. So this is where you got kind of the data science and the critical thinking comes into the problems. Is you got to look at the data, and before you even look at it, hopefully set some boundaries of what is good, what is bad, what are you expecting to see, and see if all your data looks good. That's something I do when I pull in data is this meeting my expectations? Are there things that I don't expect in the data? If so, what? And one of those would be the I didn't get a value from the vehicle, and so I've got to drop that out of the way. And Pandas handles drop NA or not a number well. It's able to exclude them from the calculation automatically. It doesn't throw a fit like some other programs might, just for instance. So does that kind of get to what you're talking
perfect
about?
Thank you.
Yeah. And so just a beginner mistake, I dropped rows after I did some sorting and filtering. And so I went back at the data and I had, trip begin. I tried to find trip begin, and I did that before dropping NA rows. So some of my rows that were labeled, I did my feature extraction to find the beginning row. It got lost because I did a drop NA and I did drop NA all. So if any column had no data, then the whole row was just gone. So just a beginner mistake. I spent hours just scratching my head as to where did the data go. So anyways, there's another question. I think.
Yeah, just another question about your example. So going back to this, like the feature extraction. So the problem you're trying to solve here, you don't just try to identify. Well, actually, let me ask you: are you trying to identify if the person got sunburned, or are you just trying to be like, okay, let's just say something about the sun exposure of this person? Like, which of the two problems you're solving?
You could do both. I think
Right,
you're right. Yeah, I think you're right. Yeah, I think you're right to. It's a good. You're on the ball because I'm not including any rest. Right. There's no recovery period in this example. So if that's what you're getting at, no, this is not a great way for the world to figure out if they're going to get sunburn or not. It's just trying to simplify a pretty complicated problem. But you're 100% on the ball. You can do the same thing and say, if I get sun exposure above a certain amount, but I have time at 0 UV index, again, this is just a random data set, unfortunately, just for example purposes. Do I have enough time? Do I have a sufficient rest period? And you could find the same, you could do the opposite comparison, right? This comparison is greater than, am I greater than the index? You could say, rest period, you could find rest periods in the data based on the UV index being less than. Does that make sense? Is that kind of what you're getting at?
Yeah, I was trying to get at the, like, let's say you get like 90, 90, 90, like the person can get sunburned in that, but then if you have labels, you kind of won't see it, the same way. But yeah, I see your point of the rest periods. That makes sense.
Yeah, so not the best example. I realized kind of late that I didn't want to share company data that I was using. So I tried to make up something a little bit fun. But yeah, 100% right. This is maybe not the best way to figure out if you get sunburn or not. We're just trying to identify events. And yeah, it's maybe you'd want to know the amount of sunburn over a period of time of the day is maybe more thorough. This is just trying to, again, going back to the example of I've got, if you do something continuously, it's, this is not inclusive, I guess you'd say, of all the opportunity to get sunburn, right? This is just saying, did we meet the criteria? Sorry.
Sure. No, but I think it's a reasonable way how to go about the exploratory data analysis, just to see how your time series looks, kind of, at least on the high side. So yeah, I mean,
right. Yeah. So yeah, it's just, this is obviously, not the world's best definition of, sunburn and a model of sunburn. It's highly simplified. I agree. But yeah, a few more real world problems. Any other questions first though? Good questions, though. I appreciate them. You're picking out all the shortcomings of this presentation. So I appreciate that. Agree 100%. Yeah. I come from a fierce part of Ford where you get torn apart when you present in our group. It's so it's all part of the fun. All right. So yeah, another thing, real world problems, you get to make up your own definitions, which is a blessing and a curse. I don't have a camera on the vehicle. I can't see when a customer appeared and disappeared. So I've got to figure out how to statistically describe. And I looked at the median of the sample. And again, another gut check of, does my data look good? I looked at the median raster, or the sampling period of the data, and I multiplied that by a certain amount to get a rest period or a time off period to say the trip was over. And cognizant, maybe I'm missing data, maybe data is getting lost and I'm declaring a trip based on bad cell reception, right? But so I applied a few different, this is just kind of guess and check of, I applied a few different time delays between data in order to describe what a trip was. So just, working with real data and real problems and making stuff up as you go, you very open-ended. You got to make up things and test and guess and check and write down your work. That gets me to my next point for programmers: make a test data set. There's continuous integration as a fair, somewhat new principle in coding, and that's having the ability for your code to test itself. And Dan works on this in functional safety, but what do we expect the system to do, and what are some error states that we're afraid of, and how can we feed the system something that we know is a problem, we want it to respond well. So that's where a test data set comes in, something that you actually manually go through, you take a sample of the data, something manageable, and you say, all right, well, I'm looking for UV index above 7. All right, the start was here, the end was here. Here's my first event, So really important to, this is 60 minutes out of 1,000 in the data frame I made. But it's really important to make a test data set, write down your answers, document everything. That's me being a nuclear engineer in the Navy, is you learn to write things down. Because if you didn't write it down, it didn't happen. And then also just visually working through examples, working my way across the data frame column by column and making sure every column makes sense, going down and saying, in this case, we're looking for greater than 2. So this is 2. It's not true anymore. So I've got to change from true to false. Here's my 3. So anyways, just working through your data, thinking visually, making sure things make sense and you understand it is really important. For me anyways, maybe I'm a bad programmer, but just to make sure you really understand what you're working on before you go present it to other people, I think is very important. So that's all I've got. I think we're out of time, but yeah, 8 o'clock. Any other questions?
Is it possible to detect events that are multiple rows, like a profile?
Oh, like would you try to extract the derivative or something? Is that
Well, or say your event is, you've got one value and the next row is twice as big and the next is, 3 times as big, and then it drops down and you call that all one event?
Yeah, I think what you do first before you start looking for events is you'd extract and say, I think this is a big enough one, but you'd say, you'd go over here and make a new column that is, and there's a shift command that makes it really easy in Python, but you do this column is equal to this column shift 1, which, or this row minus this one or divided by this one, shift 1. And that will get you that comparison of, if you're looking for growth, yeah, you create a column here called growth, for instance. And if you're looking for growth greater than 50%, then you do your comparison on this growth column, right? You do your feature extraction to get your growth, if that's what you're really looking for, right?
Okay, so you can compare data from row to row.
Yeah.
That way.
Yeah, 100%. Yeah, that's something I created. Time deltas. I had time stamps in the data, but I wanted to know how long the difference was between them. So yeah, 100% I did that. It's there's a command in Python or Pandas called shift, and it allows you to do operations like that. And you could compare, shift 3 would be 3 rows below, right? So yeah,
okay.
Really easy way to do those type of operations where again, you care one row to the next, the relationship between them. Yeah, very, very important function, and it's pretty easy.
Thank you.
I have another quick question. So I'm assuming, in your like in your work, you're faced with like data from all kind of different sources, and I'm assuming you do some kind of fusion of those. Can you maybe give an example or two, like how you like fuse 2 signals to extract something interesting? Like just any examples off the top of your head. And I understand if you can't talk about this, that's fine. I'm just curious if you can give any examples. Does that make sense as a question?
Yeah. Oh yeah. No, 100%. Yeah. No, I do that. Don't worry. Yeah. If I could show you my browser, I mean, the number of bookmarks I have with different data sources and things like that. Yeah, it's mind-boggling. But yeah, you have, warranty claims. You can attach warranty claims to how a person operated a vehicle, for instance, and those are 2 different data sets. And Python, again, is like a relational database where you got join commands, for instance, and join inner outer. You'd match on some kind of identification of the vehicle. So you could go through a database and pull out a bunch of information and then fuse it together based on some identifier between the common identifier between the 2, if that makes sense. So a lot of my work is, troubleshooting, something went wrong. Okay, what happened before something went wrong, or what caused the fault? So yeah, 100% you're going from in the time domain, especially, all right, well, effectively, how was the vehicle built? Well, that's something from a year or 2 ago. So you've got to combine things that happened in the past on a vehicle by vehicle basis. Does that make sense?
Yeah, thanks. No, it does make sense. I guess I was kind of curious if you have like a specific example of like, let's say you like looked at like RPM versus time, and then you saw that like engine blows up after somebody runs, I don't know, 10,000 RPM. You know, like kind of you have like engine explosion versus time and RPM versus time. If you have like a specific example that just comes up, does that make sense?
Yeah, no, I can't go into those kind of details, but yeah,
Okay,
something, I mean, yeah, things like that, you know, problems happen on vehicles, all kinds, but yeah, sorry, I'm no
Yeah,
gory
absolutely.
details, I apologize, but
No, no, thank you.
it's all part of the job. Anything else?
Is there anything in Pandas to turn your time history into an FFT?
Yes, I'm pretty sure there is. I don't know that I've done it, but I do have the Pandas website up, and that's, I'm reminding myself of things because everything's so huge in Python, but there's definitely I mean, it's a bullet here, time series. I'm pretty sure, yeah, frequency conversion, yeah, 100%. Yep.
Okay.
And yeah, so like here's an example of, you know, what does exist, a moving window analysis, but I don't want to know a rolling average. I want to know when my event occurs, right? And so that's where I've kind of gone a level beyond what I know exists anyways, is, you know, moving window, great. 100, you know, moving window rolling averages are really important. Definitely a good analysis to do, but what if you want to create your own window, right? So, but yeah, there's definitely support for time series and Pandas.
How much time data is stored in modern cars nowadays?
I mean, they all have a clock like a computer, but you know, I mean, time series data?
Yeah, like time history data.
I think it depends by manufacturer. I can't really go into that either, I don't think. But yeah, no, it's super. I
A
mean,
lot
it's
of data.
critical. Yeah,
Yeah.
I mean, it's what's kind of fun about vehicles is they're just a data creating machine. Everything is run, you know, they're run by computers. So obviously computers can generate data very readily. But as I've learned from experience, there's a lot of layers between, you know, that data that is being created and you being able to do something with it. And again, data science is going from here's my data to convincing someone that, you know, you're right. And that's where data science, I've seen definitions, I don't like them, of, oh, you use machine learning algorithms. I think there's a very weak differentiation, you know, between that and analysis and analyst, data analyst versus data scientist. But it's just one of those, for me, it's the science of here's my hypothesis and I've proven it. And it's really just statistics. Data science is just statistics, you know, on steroids with computers doing all the heavy lifting. But, you know, what is my hypothesis? What are you trying to prove is something, you know, it's very different than maybe what you could say an analyst is just, you know, looking at the data and, you know, here's something interesting versus trying to prove and convince people.
Yeah.
Yep.
Thank you.
Any other questions for Xander?
If anybody's interested, I popped a link into it's actually a Canadian website, educational website called Lighthouse Labs, and they just finished a 21-day challenge. But the tutorial is quite excellent, and it's all done using Jupyter Notebooks. So the same environment. The only difference is this is online instead of like an Anaconda, like Xander's doing. But it's quite good. It gets a little bit heavy, and sometimes, you know, you have to take a bit of a leap. But I just did it for myself as a refresher, and I liked it.
Good.
Thanks for sharing that. Any other questions for Xander about anything?
I think I have a general question. Just in general, like including Pandas, where do we go? I mean, so far I've been taking all these tutorials and whatnot, right? And at work, I'm going through this Coursera certification through our connected vehicle guys, whatnot, and PD. But I think I need projects to do. What's a good place to start?
Oh man, you could work for me. I'm
All right.
always looking for help on stuff. So if you want to do some work, I have more than enough work, I assure you.
All right.
Of this
Realize
kind of stuff, so,
that I'm a beginner, right?
Yeah. No, I'll send you stuff. Don't worry. I'll take you up on that because that's the difficulty I have at work is that there's so many projects. I end up being a project and program manager or project manager versus actually doing the work because our group is so swamped. But yeah, if you want to work on stuff, I'll try to, create a small project for you if you want to practice. Or if you want to like reuse what I use and, but yeah.
That'll really help.
Do you pay?
Yeah.
I'm always doing utilities.
Yeah, that is that's the tough thing and with work is like, am I getting work done or am I helping everyone else get their work done? So yeah, balance.
Any other questions for Xander before we end?
Thanks so much, Xander. That was interesting.
Cool. Glad to hear it. Good questions. I appreciate the feedback.